Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Geometry Common Core Regents exam, problem number 15. If you want to access these exams anywhere in the world, go to nysedregents.org, click on the appropriate tabs. So here's the problem. The coordinates of vertices A and B of triangle ABC are A, 3, 4, and B, 3, 12. If the area of triangle ABC is 24 square units, what could be the coordinates of point C? And then there's 3, 6, 8, negative 3, negative 3, 8, or 6, 3. So I would recommend you pause the video, try the problem on your own, see if you can get it. So if you didn't think of drawing a diagram, then now really pause the video and see if you can get it. Because really every geometry problem should have a corresponding diagram drawn. Okay? So how do we go about this problem? One way we could go about this problem is brute forcing it. Graphing the points. So 3, 4. 3, 4. Right? That's point A. And then 3, 12. 8, 12. Is right here, okay? That's point B. And then doing one at a time, plotting these other points and actually calculating the areas of those triangles. And if we get an area of 24, then that's the answer. So brute forcing it, you would find that in fact this is the answer, okay? But why is it in fact that this is the answer? And let's say, for example, 6, 3, is not. Well, 6, 3 is a right triangle, base 3, height 8. 3 times 8 divided by 2 is 12, okay? 3, 6 makes a degenerate triangle, so that's not the answer, okay? 8, negative 3, okay? 8, negative 3 makes a triangle that's a little lopsided, so it's hard to see the area this way. Oops. Okay, but the height is from here to here. If we treat this as the base, then the height is from here to here, and this height is 8 minus 3, which is equal to 5. And area is equal to base times height over 2, which is equal to the length of the base is 8 times the height is 5 divided by 2 is 4. 8 divided by 2 is 4 times 5 is 20. Which is not 24. Okay, so that's brute forcing it. But maybe we can get it in a little more theoretical way. And this is how we can get it. We know that the area is base times height over 2. All right? So let's write this down. Area equals base times height over 2. If you found that you tried doing this problem without even writing down the area formula, you're probably going the wrong way. A basic idea of this is we're talking about areas. Say, hey, we should write down the area formula. That's just an obvious. So don't overthink this question and then underthink the fact that we have to do something as simple as write down the area. So 24 is equal to, let this be the base, 8 times the height is unknown over 2, which is equal to 4h. Divide by 4, and we got 6 is equal to the h. So the height is 6. So as a result, if we're going to draw a height, the height has to go 6 units in either direction, 6 units this way or 6 units this way, which makes the y-coordinate 3 plus 6 equals 9, or this way 3 minus 6 equals negative 3. So that coordinate is negative 3. And that coordinate is 9. Any point with an x-coordinate of negative 3 or an x-coordinate of 9 is going to be an appropriate answer to this question. And only those points are the ones that are appropriate to this question. So, and that's the fact is that 3 is the only one that has that property. The other points have an x-coordinate of 3 or 8 or 6. So that's not the answer, right? Does that make sense? Hopefully it does. Listen, I know you can do it. Keep working at it. We have an extra problem here for you to practice if you want extra practice. If you didn't want the extra problem, just hit the next button and go on to problem number 16. So here's problem number 15. The area of a rhombus satisfies the equation A equals 1/2 d1 d2, where d1 and d2 are the lengths of the diagonals. Now we have this formula. Great. So what is the area of rhombus OPQR with vertices the origin O, vertex P 3, 4, and R 4, 3? Well, why don't we do it using the fact that the diagonals bisect each other? Now, if you didn't think of drawing a diagram, well, you might get this question wrong. So draw that diagram. Okay, so I draw my x and y axes, okay? And I know that the origin is one of the points. Okay, so let's get some red here. Origin is one of the points, so this is O. Point P is 3, 4. 3, 1, 2, 3, 4. There you go. Point, let's get down a little bit more to the side. Point Q, the point 4, 3. Okay. And then point, I'm sorry, this is P, this is R. So Q is somewhere around here. How do I know what it is? Because of the symmetry of the problem. This is to go from it has two pairs of parallel sides because it is a rhombus because it is a parallelogram. So this, to get from O to R, I go up 3 over 4, and to go to P I go up 4 over 3. So to get to Q I go from R up 4 over 3. So that's 5, 6, 7, and 5, 6, 7. So that's the point 7, 7. Okay? So now how do I get the diagonal lengths? It's actually not that bad. This length has length down 1 and over 1. So PR is equal to the square root by the Pythagorean theorem of 1 squared plus 1 squared is equal to square root of 1 plus 1 equals the square root of 2. Okay? OQ is equal to the square root of, let's see, 7 squared plus 7 squared. 7 squared plus 7 squared is equal to the square root of 98, which is equal to 7 rad 2. So the area of this rhombus is equal to 1/2 radical 2 times 7 radical 2, which is equal to 1/2. Radical 2 times radical 2 is 2, so 2 times 7, and so that's equal to 7. Okay, so that is in fact the area. Now, if you didn't know how to get this answer, what you could have done was drawn the parallelogram and then maybe drawn a square. This is an alternate method of doing this problem. Drawing a square, it ends up being a any rectangle, but it turned out to be a square around the rhombus, and calculating the negative space. So I could have split this diagram up into this, and this. This square is height, base 3, height 3, that's 9. 3. This is just an alternate solution. 3 by 4, 3 times 4 is 12 divided by 2 is 6. That's area 6. 6, 9, 6, 6. And the whole square is 49. Minus 9, minus 9, minus 6, minus 6, minus 6, minus 6. And that's equal to, you could do the arithmetic, is 7. Okay, 6 times 4 is 24, plus 9 is 23, plus 9 is 42. 49 minus 42 is 7. Okay, so that's an alternate solution. Definitely listen. I know you can do it. I know you can do it. Keep working at it. And thanks for watching, and stay tuned for the next video starting right now.